So I'm making this tutorial in order to show you a basic example of how to write a smart contract, how to write with Solidity, and how to deploy it using Ganache. So we're going to be using the Truffle suite in order to get started. So Truffle suite is a suite of tools that helps and make it easy for developers to write smart contracts, deploy, test, and interact with the blockchain. So I'm going to show you the few tools that we're going to be using. So first, Truffle, in order to make it easy to compile, migrate your smart contract from the Solidity syntax to bytecode and also ABIs. ABIs are interfaces, JSON formats in order to interact with your smart contract from a client-side application. We're going to be using React to create the application. So this will be the decentralized application built with React. Next, we'll use Blockchain, which provide with the personal and private blockchain nodes to interact with the Blockchain Ethereum. So we're going to be starting with that. So first, I'll walk you through our project. So let's go have a look on the project that I'm providing. Actually, on my GitHub account, you'll find one repository providing you with the final example, but you can have a quick look to see how it's built. So you've got the contract, the one we're going to be writing. It has one variable, private, with a string of string type. You've got a constructor, so every time you deploy a new smart contract, you can have some basic setup. Here it's going to be, we set this variable with the value welcome. And we've got functions. So the first one is to write to the blockchain, and the other one is to read from the blockchain. So we'll read the value which is stored on the blockchain with this smart contract. So you see this is very simple, and the last version of Solidity is 0.8.3 at the time of recording of this video. The other tool that we're going to be using is Metamask. Metamask is a browser wallet in order to keep your cryptocurrencies. Here you've got all the instructions of how to install this one. So for Chrome, or it's available as well for Firefox, Brave browsers as well. So it's giving me the options to download from Chrome because I'm using Chrome. We're going to be using React, obviously, so it's not going to be a course. It's as a reminder, this is going to be a fast forward, very quick start to get started with smart contract Solidity, and like it's a very quick example of a dapp. So we're not going to be going over React fundamentals, so you should know about how to write, how to create a component, how to deal with the state, how to access props, how to pass props from one component to another. We'll use Web3, which is a lightweight library, allowing you to interact with your smart contracts and the Ethereum blockchain and make your smart contracts interaction with the smart contract persistence to the blockchain. So here is one example. You've got different utilities and methods that you can use on your Web3 objects. First one here is to create a new contract, a new instance of your contract. After that, you're going to be able to use methods, the methods of your contract using Web3 as well. So first, I'm going to open my VS Code application, because this is where we're going to start writing our contracts, which is already done. So what I'm going to do is just erase all of that. We're just going to do as if there was nothing. We're just going to keep this line, which is now giving you a license. This is mandatory with every contract with Solidity. I'm naming this contract message storage.sol. This is the extension, and I'm going to here the documentation for Web3. So we're going to find one quick basic example of a smart contract to get started. And actually, you should look for Solidity smart contracts. You've got the documentation here, and this is giving you like this example of a smart contract. So what we're going to do is copy this one. I'm going to copy this one, and you'll see that this is not very up to date, because now the version of Solidity is closer to 8. And in order to specify the version of Solidity, you do pragma Solidity, the correct 0.8.3. Here you go. And instead of calling this one simple storage, I'm going to call this one message storage. And I'm going to have one variable as well for this one, but this will be string. And I'm going to call this one message, and always end your statement with a semicolon. So after that, we're gonna name our function differently. It's gonna be the same setup. First, we have a function which is to set your variable, the value of your variable. So it's going to be, here I'm going to name it, here I'm naming it right. And you always specify the type of your local variable. So here it's going to be string, memory, because this one will never be persisted. It's never persistent, so it's just something which is going to be erased once the transaction of writing is done, of your function is done. So this one is not going to be kept in memory, and it's going to be string memory message. Here we go, and we're going to set this temporary value to my stored value, which is message right here. And it's going to be public so I can interact with it outside of my smart contract. After that, I'd like to be able to read this one also, and it's going to be public as well. And because it's something that we just use to read and not to change the state of the blockchain, so we're going to add this keyword, which is view, and it's going to return a value as well. And this will be string memory as well. And I'm going to name this one MSG for message, and I'm going to return message. Next step will be to do the migration. And for that, we're going to migration. Here as well, I've got some boilerplate code that I'm going to erase. I'm just going to go quick. We're going to keep the model exports. Here we go. And here at the top, what you do is first have access to your Solidity contracts with artifacts require message storage. And you'll see that this is just like the name of the contract, message storage. Okay. After that, we can have a quick look, again. So I've got my GitHub here repository. So we can have a quick look inside this section, which is for migration. And the reason we put numbers in front of it is because it's just to give indications to Truffle of how, in which order to do the migration. So first, it's going to start with initial migration, this one. And second, it's going to deploy the contracts. This is done asynchronously. So I'm just going to copy and paste all of that and put that inside a try. And we're going to catch if there's any errors. So just in case something goes wrong, and it's going to be here, catch. And I'm going to simply console log this one. Here you go. So first it's going to be, I'm going to use deployer. So it's giving us in the callback this object. I can call deploy on this, the deploy method, and then pass as a parameter my message storage. Finally, I get an instance of this contract deployed, and I'm going to deploy this one with the address. So once you've got the address of your contract that this is properly and successfully deployed, so once you're done with the deployment, so you're going to be able to interact with it. So that's going to be the next step. And we're going to go to Truffle config because we're going to be doing a few things in here. Truffle. So let's go to Truffle. So we're going to their documentation for Truffle, learn more. To install Truffle, you've got the npm install. And we're going to the documentation to find some more details about Truffle. So we'll see. So after the installation, you've got here a quick start giving you an example of how to configure your Truffle environment, because you'll need to specify on which network you want to deploy your contract. So we're going to be using Ganache, very simple. You can also deploy on the testnet, but we're going to do that in a separate on a separate occasion in a separate video. For now, I just want to show you how to deploy your contracts here on the network which will be developed. We're going to use Ganache. So you can go ahead and install Ganache. I'm going to open mine in order to have one node running of a private blockchain. So I've got one which is already created. You can go ahead and do a quick start or go ahead and create a new workspace. To create a new workspace, what you do is just like this. You follow the instructions, very easy. You've got all the setup and you can click save workspace and you're good to go. You've got your mnemonic, your seed phrase. Do that with Metamask. Metamask is this extension that you should install. You can here follow the instruction and then install this one. So I've got mine up and running, but what you should do in order to use Metamask together with Ganache, you should create a new custom RPC. So I've got already one installed and created, but if you want to do just like me, you can do ganache. So you're the new RPC URL, you should get it from ganache, like this. So I already have one, so this is giving me this alert. After that, just specify the chain ID just like this. So what I'll do is just change one number like this, because I already have. So I'm just going to proceed as if I had no network with that name. You just copy and paste the same number that you find here, RPC server. So this is the one that you should copy and then add in this section, new RPC URL. And then you click save, and then you're going to be good to go. So if you are all set, you should get one account name, ganache, or the other name that you picked. And once your ganache is up and running, so make sure that you have your ganache up and running at the same time as you select this one. Otherwise, you may have something that keeps spinning like this because your ganache is not open or up and running. So go ahead and select your ganache like this. And what we're going to do is make sure that we have our mnemonic set up with ganache. And I'm going to do import using secret recovery phrase like this. It's going to ask for a password. Here we go, restore. And you'll see that you're going to be set up just like you have on your ganache. So you'll get this first account which matches this one. You're good to go. If, for example, so for now we don't have any application running, so we have no dapp running, but let's say that you want to click on your MetaMask and make sure that it is connected to the current website. You can go to connected website and do manually connect to current site. And we're going to do next. So now we're connected. You'll see that now you've got 100 Ether. This is fake Ether. You see it's not real Ether. We're not on the mainnet. We're using a private ganache network node in order to test our smart contract. And you'll see that this one matches the same account right here. I'm going to put them side by side. This is the same address, and you see that now we have a balance of 100 Ether. Once we do our first transaction, you'll see this value going down, and it's going to be similar. So let's look at the Truffle config again, because now I have a few things to show you. So first, you'll see that this port is similar to the ganache ports. This is 7545, and so we're done with this part. And we also specify one object, which is the compiler, and this one should match the value, the version of your Solidity contracts. Okay, otherwise you'll get a negative error feedback telling you that the compiler don't match. So we'll start with that. So first, if it's not done yet, I'm gonna run npm install in order to install all the dependencies. I'm gonna be doing the same for the client application. So right now I am inside the client React application. I'm gonna run as well. You see that I've got a package JSON, very standard, like it's the one that I created with create React app. Let's go back to the Truffle here application, and what we're going to do is this command, which is truffle migrate. We specify the network, but now we just have one, which is develop. So this will migrate and deploy the contract on the private blockchain using Ganache, and here we go. Press enter. So it looks like I've got an error with found version pragma but failed to parse it. Okay, let's check this out. In the contracts message storage line 2, remember, as I was specifying earlier, that you should always put a semicolon at the end of every line of code. So this is what was missing, line 2. I'm missing one semicolon, so I just added it. Oh, I've got one typo. So here it's going to be memory. So I meant to write not message, but memory, like the keywords, the same as here, line 7, memory to specify that we're not going to keep in storage any local variable. It's going to be erased as soon as the transactions or the function is completed. So that was one typo, so my mistake. I just corrected to memory, and we should be good to go. I'm going to run again truffle compile. Perfect, compile successfully. And now I'm going to do truffle migrate network develop. Here we go. And we're done. So it's going to tell us someplace that now the contract is deployed at this address. Okay, so we're ready to go. We're ready to interact with our contract. And now you're going to check, we're going to check, you see in truffle config, there is this line that we specified, which is to indicate in which directory we would like to generate and build the JSON and interfaces of the contract. Here, as a reminder, the way it works with a smart contract is that we deploy and we migrate, and we always have a bytecode which is generated, which will be used and read at a low level by the blockchain. And as for us, we're going to get something which is more readable, which is in JSON format, and we're going to use these interfaces in JSON format to interact with the blockchain. And this is this part right here that we're going to find here in this place in src contract right here. We'll find this JSON file with an ABI, and we're going to find every input that corresponds to our smart contract. So first, the variable, which is of string type, the function write, which is public but non-payable. So that's a function that we're going to use to write to the blockchain and to set the value of message. And we've got another method, which is read, which is allowing us to return the value, the current value of the message, which is of type string as well. So now we are going to the client side, and what we're going to find inside a very basic setup. We've got this get web3 method utility that we're going to use to first check that we've got an instance of web3. So what we find in the app.js is we import the JSON file, like as this object message storage contract. And I have defined here this get contract, and this is to get an instance, to first get an instance using web3. So here you can recognize the web3eth contract method that takes two parameters. So first the ABI, so that is the JSON format that we specify in the first parameter, and second you specify the address of your contract. So you could see that our contract was deployed to one specific address, so we must specify this one. So once you've done that, so this is a promise, this is returning an object of web3. This is returning also an instance of the newly deployed contracts. Finally, the accounts that we also get using Web3. So this is this method which is giving us a list of all the accounts available on this node. And we will always use the first one as an admin. And you'll see that this one corresponds to the contract used to deploy this smart contract. So this should match this contract number, this account number. So we're going to call this get contract from a use effect. And again, remember that I've deployed and pushed this code on my GitHub account, so you can feel free to copy it and get a quick start. It's a quick example of how to get started with Solidity, but also with dapp, with a decentralized application. So what we'll do is first get the instance of Web3, instance of the contract, and then the accounts. Okay. For this method, this utility, I specify the name of my contract that I get from my JSON file. You see it takes one parameter. Okay. All right. Let's go back to the use effect because we want this one to run as soon as the component is compiled. Okay. So we're going to set the local state to get the Web3 object, the accounts, and finally the contracts. because each time that we do an interaction with the blockchain, we'll make sure to get an instance of our contract. For example, here, which is a function which is used to write to the blockchain, so it's going to be called update storage. We get the local value of contracts every time that you use a method from your smart contract. So it's going to be from an instance of your contract. Then you call methods and you'll get a list of your function from your contracts. Remember that this is write. And let's pull up again our contract. So we've got two functions, write and read. Let's go back to app. We've got this function write. We specify, so it takes one parameter, which is a string value. We specify the state local value. So this is something that we take from an input. I'll run this app very quickly so you can see how this looks. Very simple and basic as well. And each time that you make a transaction to change the state of the blockchain, you should always specify the author. Finally, we get a transaction status each time that one transaction is made and finished with the blockchain. And I'll just check that this one returns true to do the following, which is to change the state of my component. So I'm going to change pending to false. And finally, I'm going to run this function, which is also to interact with my smart contract, but this time I'm going to read from it. Again, I'm going to call methods and finally read and call. So this one is when you read from the blockchain, you always specify the name of your methods followed by call. We get a response. This one will correspond to, remember, this value that we return here with this value, which is a view function. So meaning that it's not going to change the state of your smart contract, but it's going to return a value. So the one which is stored, which is your message. So it's going to return whichever current value of your variable message, which is of type string. So this is what it does here. And again, we update the local value state of the component in order to be able to read right here from storage value. So let's see how this works. Have a quick run. So I'm going to go to client, my React application, and I'm going to run npm start. Here we go. So first it's going to ask me to connect for now. So what I'm going to do, MetaMask is asking me to connect to my node using one account. And we'll see that now the value has already gone down. And you're going to see that it matches as well. How it matches, you'll see here on my Ganache account. So we've got the same account, which has just got down so by a few Ether. And this one matches, so the same account, which is from a MetaMask right here. So every time we make a transaction, we'll use some fake Ether, because every time you make a transaction, this is not free. It actually costs some Ether, but this is fake. We're not actually using real money. So here we go. So now we can see that the Truffle box is up and running, installed and ready, and we can click below to edit the message. But for now, we don't have any message right now. So what I did is here for this contract, we don't have any message. So, but what I'll do, we're going to compile and migrate again. This, we're going to make a change to this contract. So I'm going to add a constructor, meaning that I'm going to make some setup. So as soon as I deploy this contract, this new contract, and I'm going to put welcome for this one, because for now I don't have any value. Or what I could do as well, I could do also something like that. It boils down to the same. I could do like an initial setup, initial value. I'm just going to do like this. I'm going to deploy again my contract. I'm going to go back here. So make sure that I am at this level of the project. Right here. So make sure that you are at the level where you have your Truffle config. And I'm going to run again Truffle migrate network as specified develop. And because I already have like migration ready and already have examples of my contracts, already have contracts deployed, I'm going to ask for a new deployment and then specify this flag, which is reset. And I'm going to press enter. So that's going to deploy a new contract at a new address. Here again, I missed the semicolon. So I'm going to run again. And then you'll be able to see that we've got a new address. So that's going to be the same account, you know, remember? And this is costing, so each time that you do a deployment, this is costing you some gas, even if this is fake Ether. And if we check up, we'll be able to see that we've got a new, like here, like now we've got a new address for this contract. Here we go. So we don't need to change anything for the client side. It's good to go. It's just that now, transaction pending, I'm just going to refresh. Here we go. So now we can read welcome. And for this application, so what I need to do is just to click on it, and then I can check and say greetings. I can change my message. And you'll see that when I press enter, it's going to make a transaction, which is to ask to write to the blockchain. So now I've got transaction pending. I can confirm, and then it's going to change my message to greetings, and you can see that we've got a new transaction now. Perfect. So if we check now in Ganache, you'll see that now we've got some transactions. So each time that you do something new, you'll see that now we've got a new contract call. We can check this out. This was to write to the blockchain that we've done from this account. So I'm going to let you play with it. Remember that I put this contract, I made it available right here. Thank you for watching.